Hey guys, today we'll be talking about geometric and binomial distribution. A binomial distribution can be thought as simply the probability of success or failure outcome in an experiment or survey that is repeated multiple times. The binomial is a type of distribution that has two possible outcomes. The prefix bi means two or twice. For example, a coin toss has only two possible outcomes, heads or tails. Taking tests could have two possible outcomes, pass or fail. Don't you think it's funny that the name really does define itself? I think it kinda is. Moving on. The formula of binomial distribution is defined as b, x, and p equals to n combination x times p of x times 1 minus p n minus x, where b equals to binomial probability, x equals to total number of successes, pass or fails, heads or tails, etc. P equals the probability of success on an interval trial, and n equals to number of trials. So, the example of one of these questions are: Nikolai has shown to be one out of 5 people that are particularly allergic to pimento peppers. With this, a group of 25 high school students volunteered to try a new treatment. I, what is the expected number of allergic people in the group? Double I, what is the probability that there are exactly 3 people who are allergic and the second and no more than 1 people of the group is allergic? And for the final question, how large a sample would be needed for the probability of it containing at least one person that is allergic to be greater than 95%? So, the solution to these questions are: for the first one, the solution is modeled by the binomial distribution with n equals to 25, p equals to 0.2, and q equals to 0.8. The number of people is denoted by x. For the first one, the expectation number is 25 times 0.2, which is 5 people. For the second one, px equals to 3 is 25. C2 times 0.8 to the power of 23 times 0.2 to the power of 2, which is 0.07. For the second one is px equals to 0 plus px equals to 1, which is 0.8 to the power of 25 plus 25 combination 1 times 0.8 to the power of 24 times 0.2, which is 0.027. So for the third one, let the sample size be n, so that x and b n equals to 0.2. So the probability of them being allergic is 0.8 to the power of n. That means for px less or equals to 1 is 1 minus 0.8 to the power of n. Therefore, to find how many people are required, 1 minus 0.95 to the power of n is bigger than 0.8, and then 0.8 is less than 0.45, and log 0.8 log, and then you'll get for your final answer, which is 4 people are required. There are 2 types of binomial distribution. This is a second example. The binomial distribution formula can also be written in slightly different ways, because n combination x equals to n factorial over x factorial n minus x factorial. This is because the binomial uses factorials. So for the second example, 80% of people who purchase pet insurance are women. If 9 pet insurance owners are randomly selected, find the probability that exactly 6 are women. To do this, we're using our example question, which is n equals to 9, x equals to 6, so we put those in, which is 9 factorial over 9 minus 6 times 6 factorial, which is 84. Then we are given t equals to 80% or 8, so our probability of failure is 1 minus 8, which is 2, which is 20%. So px equals to 86 equals to 26, 0.26244. Work the formula n, and then with that you will get 0.17.
Our question today is: Wally goes hunting with her slingshot, but average chance of successfully hitting a target 50 meters away is 0.05. What is the sum of the expected value and variance of the number of shots it takes for her to hit a bird? First, let x be the random variable that represents the number of shots it takes for volley to hit 50 meters away, as each shot can be thought of as a probability P equals 0.05. The random variable x obeys the geometric distribution with P equals 0.0. The expected value and variance of geometric distribution with probability P are given by the formula E bracket x equal 1 over P and V bracket x equal to 1 minus P over P square. Therefore, we have E bracket x plus V bracket x equal 1 over P square equals 4. Let us prove that E bracket x equal 1 over P and V bracket x equal 1 minus P over P square. The probability distribution function of a geometric distribution with probability P is given by F bracket K equals bracket 1 minus, where K is positive integer, hence we have this. I cannot speak too long because I have a free account for photo, so I'm sorry for the income. Let x equal 1 minus b, since bracket x plus over that 1 we have 1 plus x squared plus x cubed plus blah 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 equals, differentiating this formula we get 1 plus 2x plus 3x squared plus blah 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 equals 1 over bracket 1 minus x. We supply x bracket x equals b over 1 minus 1 minus b squared equals b over b squared. Now multiply both sides of 1 by x to obtain x plus 2x squared plus 3x cubed plus blah 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 equals x over, differentiating which with x respectively, 1 plus 2 square x plus 3 square x squared plus, this implies that E bracket x quadrat equals b times 1 plus 1 minus 4 over 1 minus 1. Hence the variance is v bracket x equal E bracket x squared minus E bracket x squared equals 2 minus b over b2 minus 1 over.